Good afternoon, class. This is Miss Martin, and this is video part 2 for scientific investigation. And we're talking today about how do scientists conduct a scientific investigation. So, part 1, we've already discussed that when scientists conduct a scientific investigation, they use observations and inferences and they have quantitative and qualitative observations, and they do predictions. And then we ended last with talking about the 3 types of variables. So what you need is your ISN and a pen or pencil to write, as well as your notes for the lesson. So if you do not have those 3 items with you right now, please stop and pause the video, gather your materials, and come back and hit play when you're ready. But if you are ready, then we will get started, and I will promise to be under my 15-minute mark. All video remember what the manipulated variable was? Okay, it's the thing that you can change on purpose in an experiment. He was measuring the growth of the plant, so that was his responding variable. And the last one is the controlled variable. Those are the things that you can keep the same in an experiment. So during Bill's experiment, he was keeping the soil, the water, the pot, and the temperature the same. The only thing he was changing or manipulating was the type of light, which was his manipulated variable. Okay? So there can only be one. And therefore would have been inconclusive. So that's why you only have one manipulated variable in an experiment. Now, you've probably heard these words before: independent variable and dependent variable. These are familiar words for you, but the independent variable is also called the manipulated variable because it is the independent of what happens in the experiment. It's the one thing um, that you have changed, the independent variable. It's independent of what happens in the experiment. Now, the responding variable is also called the dependent variable because it's dependent upon what happens in the experiment. So the growth of the plant was the responding variable as well as the dependent variable. It was dependent on what happened in the experiment. So the main purpose of the scientific method is to answer a scientific question. Remember, In the lesson where we talked about scientific investigations, the very first video lesson, we said the first step was to question, to form and identify a testable question. And I used the example of my dog Gerard. My question was, I wonder how long it will take for Gerard to eat a bowl full of his dog food. That was my question. Um, and the steps for that were, the first one was you identified your testable question. The second one was you started your research information about the topic. Third was state the hypothesis. Just to review, the hypothesis is what you will think will happen. So my hypothesis for my statement was, I think it will take Gerard 5 minutes to eat a bowl full of dog food. And then I designed the experiment. I conducted the experiment and recorded my data. 6, analyzed the data. 7, I compared the results to the hypothesis. You write a conclusion. And then 8, you communicate your results. You share what you find with the world, with your experiment. That might have been a little dramatic, but anyways, today is one of those dramatic days for me. You have things would stay the same, there would be no reason for an experiment. So rules for experiment design. Number 1, plan for the independent variables. Decide what you're going to change and what you're going to keep the same. Plan for the controlled variables. List the materials needed for the experiment and list the procedures to be followed. You always need to start off with a list of materials. If you notice in all of our video lessons, in the very conclusion. It's a statement about the outcome of an experiment. A conclusion always tells if the hypothesis was supported or not supported by the recorded data. So, going back to Bill's experiment, his variable, his manipulated and independent variable, was sunlight. He put one plant in the window and put one plant in the closet. So when he went to go, oh, I cannot talk tonight. When he went to write up his conclusion, he was going to tell if the hypothesis was supported or not supported. So for example, his hypothesis could have been, I think the plant in the closet will only grow 1 inch. Or I think the plant in the window will grow 5 inches. And once he conducts the experiment, in his conclusion, he tells what happened. So say the plant grew 2 inches at the window, and his hypothesis was it would grow 5 inches. The plant grew, but it did not grow as much as he predicted. So that's when you tell in your conclusion, tell about your hypothesis, if it was supported or not supported. Finally, the technological design process. The main purpose of the technological design process is to solve a problem by creating a solution using technology. The steps of the technological design process are: identify a problem or need, design a solution or a product, implement the design, evaluate the solution or product, and communicate your results. So I want you to think a few minutes about anything that you know that's been a technological design that's happened in the past that you think was in the beginning a problem that someone identified, and then the solution and how they implemented it. Think about that. That's a hard one. Okay, so I was trying to think about a current technological design, and I thought Apple, the iWatch. That's been a pretty big technological design that's come up. Somebody had to think about that. They posed a question and decided to design this watch that can measure your BMI as well as your exercise and take calls and send you reminders, tell you about the weather. Um, so that's one of the latest technological designs we've got going on right now, as an example of what's going on in the world. So that's why it's important to think like a scientist, because if you can come up with something that you could create and experiment and write and start excuse me, create a hypothesis and come up with some data and design it, then you could be very, very wealthy, as well as not even the money. If you could create a cure for some type of disease through the use of a technology, that's just amazing. So anyways, this is just an example that I wanted to show you of what we're talking about today with today's lesson. And other than that, I think that's it for us today. So again, we were talking about scientific investigation. How do scientists conduct a scientific investigation? They design the experiment. They have a hypothesis. They have an independent variable and a dependent variable. They only can have one independent variable per experiment. It would be invalid if they did not. And they make predictions during the experiment, and then after they collect all of their data, they write a conclusion and communicate their findings with others. So this is the end of part 2 video lesson of scientific investigation. Hope you've had a good time learning lots of information, and don't forget to check this off on your agenda, complete your notes, and I will be checking your ISN shortly. Thanks so much, and hope you have a great rest of the period.